Okay, the second part is we're trying to find out what a rule would be. Okay, what's a rule that explains the relationship between, say, this small square and the circle, isn't it? And the circle and the big square. Is there a relationship? So we're going to make a little bit of a table here. On the top we've got the radius. Here's the area of the small square. Here's the area of the big square. So we've already done the first one. The radius was 1. The small square area was 2 units squared. And the big square is 4 units squared. Okay, so now we need to imagine like if this is, the radius is 2. If the radius of 2, and this is 2, so the radius should be here, we're using the Pythagoras rule, c squared equals this squared plus this, 2 squared is 4, 2 squared is 4, so 4 plus 4 is 8, so that would be 8 square root of 8. Okay, and the square root of 8 times the square root of 8 gives us 8 square units. Now if the radius is 2, this is 2, so that would be 4, and that's 4. 4 times 4 is 16. So we put that down here, 16 units squared. If this is 3, so it's 3 and 3, that would be 6, and that's 6. So 6 times 6 is 36 units squared. If it was 4, that would be 8 times 8, which is 64 units squared. If it was 5, so that's 10 times 10 is 100 units squared. If it was 6, so that would be 12 times 12 is 144 units squared. And if it's 7, so that's 14 times 14 is about, what's that, 14 times 14. I'm sorry about that. I think it's 196 units squared. So that's the big thing. Let's have a look at the smaller circle here. And we're starting to see a pattern here. 4 and 2, 8 and 16. Let's see, we'll try it for a third one. If the radius was 3 and 3, so that's using the Pythagoras rule, 3 squared plus 3 squared, 99 is 18. So that would be the square root of 18 times the square root of 18, and that would be 18 units squared. If this was 4, so that's using the Pythagoras rule, it's 4 squared plus 4 squared, so 16 plus 16 is 32. That's the square root of 32 times the square root of 32 is 32. Okay, and one more. If this here was 5, so that's using the Pythagoras rule, 5 squared plus 5 squared, 25 plus 25 is 50, so it'd be the square root of 50 times the square root of 50, which is 50. So you're looking at the relationship, like that's half in each of these particular ones. So half of that is 72, and half of 196 is 98 units squared. So what this is telling us is if I have a big square, and if I put a small square in it, the area of the small square is exactly half of the area of the big square. Okay? And that makes sense because if I divide this into 1, 2, 3, 4, 5, 6, 7, 8 parts, I've got 1, 2, 3, 4 parts is the small circles, and another 1, 2, 3, 4 is the big circle, is the big square. So the small square should be half the size of the big square. And that's exactly what the case is here. But another interesting one is if I draw a circle here, and if I put a square around the circle, square in the circle, is there a relationship here? And I think we can see a relationship. So if we go 2 times the radius squared, 2 times the radius squared, the radius is 1, so 1 squared is 1 times 2 equals 2. If we continue on, so 2 times r squared, 2 times r squared, 2 times r squared. If we continue that on, 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. So we can describe the relationship between, if we write a circle, if we draw a circle, and if I put a square on the inside, the area of that square is going to be 2 times the radius squared. Okay, quite interesting. If it was the outside square, if I drew a square around the outside, then it is just, this is double, so it would be 4 times the radius squared. Okay, like an example here, the radius is 5, radius squared is 25, times 4 is 100. Here, 6, so 6 squared is 36, times 4 is 144, and so forth. So that here is the mathematical pattern. Very interesting. So if I draw a circle, any circle, and if I put a square inside the circle, I can find the area of that particular square if I know the radius. Okay, because this is 2 times, and I can draw the square around it. I know the area of that square because it's just 4 brackets r squared.